So just the screen. All right, don't have to write any of this down right in the beginning. We'll do 2 examples in a second. What we've been learning, and I've been very impressed, a lot of people have been figuring this out because you initially just learned this through a video. It's about placing electrons. And electrons are always placed in the lowest energies first. So if I just do a quick summary, and if you can't quite understand it all yet, we'll get there. But a quick summary of where electrons go, they always fall into the lowest energy levels first. The lowest possible energies. Sorry, just a second. Of course the batteries would be dying right now. Why not? So, it's not your job to memorize this, but the lower energies are where the electrons go first. If you can just take this home with you at least, is that they are the lowest energy, the simplest area to be in, the least complex looking orbital looking kind of shape, these, which are called electron clouds, and then they slowly fill up more and more. It's kind of like you sitting on the couch. If you have the remote, all right, like you don't have to move much. All right, I got to do a little bit more action. I got to put a little more energy into it. Well, your path starts to get more and more complicated. And this is the sequence. And you're like, oh my gosh, wait, the colors are getting mixed up. The numbers aren't all the same. Well, there's a way that we can know this, and it's called the cheat pyramid. So there's a box in the middle. We're going to do this one more time. So you're going to draw this out. But today I'm going to show you that the cheat pyramid, there's even an easier way. So how do we organize it? Let me give you a couple quick hints if you're ever not remembering, because this gets us the order. Each energy level, which are these big numbers, we gain a what we call sub-level each time. So check it out. Energy level 1 has 1, 2 has 2, 3 has 3, 4 has 4. Technically, 5 actually has 5, and so on and so forth. But we'll never get there. It's too many. So we make a pyramid. You line up the S's, the P's, the D's, and the F's, and you gain 1 each time. To be totally upfront, it doesn't matter if you remember where to cut this off. If you went down to 7 for each, it actually would work. So please put that in the middle box. One last time to draw this, because this is your aid to help you figure out where electrons go. And then how do we remember the order? What did we do with this pyramid? What do we have to do to the actual, we have to make lines, right? The lines tell us, the lines tell us the order. So once you're done writing it in, draw the lines. And this helps us with the order, okay? One thing I think helps is writing down how many, what we call orbitals, or how many different options the sublevels have. Each one gets a little more complicated. So S's, if you made lines, would have 1, right? The P's had 3 lines, the D's had 5, and the F's have 7. So I like to a lot of times to write down 1, 3, 5, and 7 underneath my S, P, D, and F. I think it helps. But that is our helpful aid. So I still have it right there. Today I'm going to show you where that cheat pyramid actually lies. So you do not have to write any of this. This is actually from the video you guys watched like a week and a half ago. But I want you to be aware of some of the terminology I'm using. So please don't copy any of this down right now. If you're still working on the cheat pyramid, that's great. There's 5 of them. I hope you say, okay, I start at 1S. I go up, down. I go down to 2S. After that, I go down this line, and then I keep following those lines. So I just have to place 5 electrons. Okay? All right, what are these? Just so you have a little more reference. The numbers are always what we call our energy levels. Okay, you don't have to write any of this down right now. Just have a reference here. On energy levels, we have different parts. We have an S, we have a P, maybe we have a D, maybe we have an F. So we call those sublevels. Okay. How complicated a sublevel is shows us how many orbitals there are. The more orbitals, the more complicated. The more complicated, the higher the energy. Those are clearly electrons. Why do we have one going up and one going down? We call it an up and down spin, but it's more of like a clockwise and counterclockwise spin. And what it does is it creates like a, I know, it's like, wait, what? Try doing the other way. It creates a north and a south magnetic like force field, or a pole, basically. Magnetic pole. And they balance each other out. Okay? And that's why we just have to put an up and a down. And then electron configuration, sorry, forgot. This is all the hard work, and then you just plug it in a more simplistic way. Hey, 1s2, 2s2, 2p1. So let's do it together. So your first example is Cl. we're going to do two things that we already know, and then I'm going to show you two new things today. And as we're going, the whole goal is I'm trying to show you shortcuts and easier ways to show this stuff, because eventually down the road, we don't need all of it. We need just some of it. So, Cl. How many electrons do I need? 17. If it was Cl minus, how many would it be? If it was Cl minus, it would be 18, because negatives mean I have more electrons. If it's Cl plus, I'd have 16. Very important to know. So, I have to place 17. So I hope we'd all agree. I'd start at 1s, I keep going, okay? I like to go downward though, like in the last one, I went up. Well, if it's a really large one, how low do I start so then I don't run out of room? So if you start with the 1s on top, and you move from there and move down, then you won't run out of room, okay? So we're gonna fill each one. This is kind of a quick review. So it's 1s, and then I go up and down, I go to my 2s, I go up, down, so now I've used 4. I need 13 more, right? So it says I go to the 2p. As we've been doing this, the 1s, the 2s, the 3s, the energy levels line up in the same line. If you're having problems with that, by the way, spatially, your cheat pyramid is actually how it should be laid out. Like it's already there. So I would have put the 2p, up, up, up. That's another way we do it as well. You always go up first. You keep it balanced. You put as many spread out as possible. You go back. I know they filled up, but you never know. You get the 3s. I'm trying to get 17 down. So I'm at 12, 13, 14, 15, 16, 17, and I'm done. So that would be my orbital diagram, which we have been working on. If you're still struggling, you need to come in, by the way. A lot of people have been coming in the resource and getting help, and I really do feel like when they leave, they have a better idea of where this goes, because there is a repetitive nature to this. So that's the orbital diagram. Electron configuration, you don't even have to have a cheat pyramid. Just go across. Hey, that's a 1s, and there's 2 of them. There's a 2s, there's 2 of them. 2p, 6, 3s, 2, 3p, and there's 5. And that would be my electron configuration. This is the stuff we already know. So let's talk about the stuff we don't. I should have thrown this one. Whoa, okay. So, noble gas configuration. Must use noble gas in the previous row. You don't necessarily have to write that, but let's talk about that. So let me introduce you to the noble gases. File it under extremely important. These are all my noble gases. The ones on the far right, the last column. Those are my noble gases. And you're going to pick up on this really quickly. So let's relate it. On your electron configuration, you'll want to label this once. Hopefully you have a little bit of room. If not, do it on the next one. These are called my core electrons. I'll show you why in a minute. My core electrons will be what we call our inner electrons. And any electrons in the outermost energy level are going to be called, a fancy way of saying outer energy level, valence, V-A-L-E-N-C-E, if you can't read it in the back. So, very important vocab. We don't have a lot of vocab words. So when one comes up, very important to know. Okay, what's the point? How many electrons are in my core right now? There are 10. What element is 10? Neon. Whoa, that's a noble gas. Yes, check it out. Cl is on this row. What is the previous row? The second row, and that's the noble gas of that second row. So this will be my neon. That's as part of my noble gas configuration. Again, you look at the row you're on. So Cl is on row 3. You go to the previous row and take the noble gas. Noble gas of this noble gas, neon, is 10 electrons. So then what's left? The outer electrons, the ones on the outermost energy level, not part of the core, which would be 3s2 and 3p5. So 10 plus 2 plus 5, oh my gosh, it's 17. It's still 17. And if you're looking at that, be like, well, that's not that much of a shortcut. Well, that's only element number 17. I'll show you when we do an element like 56 or 55 and we hardly have to write anything. So that's the noble gas configuration. Awesome. All right, let's get to the last one. Electron shell. Okay. This is based on energy levels. So if you look at this right now, a lot of people would say, we're going to do another example in a minute, that you'd say, oh, you have 1, 2, 3, 4, 5 energy levels. That's not right. You have 5 sublevels. How many actual energy levels do you have? I see a 1, I see 2s, and I see a 3. Chlorine is on the 3rd row. So I have 3 energy levels. What electron shell notation does is it groups them by energy levels. So the first energy level, what you're going to do, I didn't do this. Shoot, I don't know if it's going to be able to write. Put a circle right here. No, shoot. Put like a dot symbolizing like a nucleus on the bottom, okay? What I'm trying to show you is this. Like if you had a nucleus, like how many electrons are in every row or on every energy level. But instead of doing full circles, let's just do halves. Circles. I used to teach it with full, and then we get these weird ovals, and then all of a sudden the oval has a flat bottom because I have no more room. And so there are 2. Okay, a lot of people would put another 2 here, but you have 2s2, 2p6. The 2 plus the 6 is 8. There are 8 on the 2nd row, on the 2nd energy level. So how many would be on the 3rd energy level? It'd be the 3s2 and the 3p5. So we would write 7. Okay? We'll do another one, and it'll hopefully kind of contrast and make sense, okay? What does 2 plus 8 plus 7 equal? 17. All right. So that one's done. We're going to do one more, and then we'll get into some new stuff. So let's go to RB. Hopefully you got this written down. Just suggestion, by the way, this is how I always write it. I just do the element or the electrons first, and then I just make the half circles after. It's not my first time. Here we go. RB, right there, number 37. Write it down, 37. We're going to do all this. Now, I'm going to do this without a cheat pyramid. And after this, in about 5 minutes, you will be able to do it without a cheat pyramid as well. In about 5 minutes, I'm going to show you where our cheat pyramid actually lies. So here we go. Make it kind of small. So we need 37 of them. Let me give you a huge hint. Anybody, can you tell me where the cheat pyramid starts to deviate from things making sense with numbers? Like when is the first time you're like, what? Where does it like jump and it's like odd? Anybody know? You know, it goes, where? 3p, because after 3p goes to 4s, then back to 3d, right? If you can remember this, it gives you so much confidence. Bomb the, if it's over 18, if you bomb this all the way, I'm doing this fast on purpose. If you bomb it all the way to 3p, because 3p is the last time before it doesn't make complete sense, that's automatically 18. There's no question. I'm just going through it. Hey, 1s. I just know that there's not a 1p. Why? Because first energy level only has 1 sublevel. Second one has 2. Third one has 3. If you have a comfort zone, hey, I know every time I just do 1s to 3p, that's 18. And I know it never goes out of order. It doesn't deviate. That's a comfort level for me. So like if you have something bigger than like 37, why take so much time in the beginning? If you can, like, this is the point that I always try to get students to kind of get to. Like, can I get to 3p6? That's 18 of them. So that's 18. Let me pass this back to you. There's a paragraph on the back. Make a line above the paragraph. You don't have to do anything on the back. The paragraph. Make a line above it. You don't have to do anything. You don't have to do anything below the paragraph for now, at least. Okay. So that's 18. Now where? Now I got to go to 4s, right? So s would go underneath the other s. So that's 20. Then what? No. I know I said I wasn't going to use a cheat pyramid, but might as well talk about it. 3D. Where did 3Ds go, you think? Next to the 3P, and it also says it like that as well. So I write it there. It has 5. How do I know that? 1, 3, 5, 7. So I'm at 20, 21, 22, 23, 24, 25. I'll go up. 26, 27, 28, 29, 30. I'm almost there. I'm almost done. What goes on after 3D? 4P. Right? 4P. So I'm at 30, 31, 32, 33, 34, 35, 36. And again, in about 5 minutes, you would have been able to tell me, in 10 seconds or less, you would have known that it actually ends in 5s1. We're going to find out how to do that in a second. It ends in 5s1. Why would I have known it ends in a 5? It ends on the 5th row. I'll show you all that in a minute. So that is the orbital diagram. We will not have to do this eventually a lot. Orbital diagram takes a long time. You're like, why didn't you just teach us without it? Because you need to understand where they all are to be able to do a shortcut to it. So just understand, there's actually going to be less and less work because we're going to be able to have understanding of where these are. So that's the orbital diagram. I hope we understand how to do the electron configuration again. It doesn't matter the order. You don't have to be like this one, this one, this one, this one, this one, then that, then just go straight across, right? And you just fill it all in. Like you should just be able to, 2s2, 2p6. Start recognizing things. If the p's are all full, it's automatically a p6, right? If the s's are full, it's an s2. You shouldn't be counting those anymore. Why is it a p6? There's 3 lines and there's 2 per line, right? A d is automatically 10 if it's full. If you have some recognition on that, things go faster. So that would be that. What do all those superscripts, the little numbers equal? Should still equal 37. That's the old stuff. If you're not strong at it, don't hide from it. You need to come and get help because once you get it, you get it. But you have to make sure you're putting in the time to figure that out. So let's talk about this. What noble gas do I have to use? Whoops, oh my God. Let's start over. RB, which one do I have to use? Krypton. I'm pointing at the wrong thing. Why do I know these are the core electrons and valence? Well, because krypton, and you'll know more in a minute, that actually equals, what do you think these all equal? 32. That equals 36. So what else do I have to write? -1. That's it. I like that a lot. Okay, let's do the electron shell notation. How many shells am I going to make? Total. 5, because I'm on the 5th row. I've color-coded it for you. I'd like you to try it right now. Put the dot. What you're going to have, you should have 5 electrons written with numbers. I've color-coded it, though, because I want you to visually see it. It's based off of the large number, right? The energy level, not the sub-level. You don't make 1, 2, 3, 4, 5, 6, 7, 8, 9. I see that on tests all the time. 9 half circles. Like that should be a problem. There's only 7 rows. You can't have more than 7. And it should look like this. Couple other pieces of information for you. You can't have more than an S, P, and a D because it's the 3rd row, the 3rd energy level. So if they're full, that's 18 automatically. The 2nd level maxed is 8. The 1st level maxed is 2. So as you get larger and larger, these will be maxed out. Like you can't have more than that. And then 8 and then 1 for this. These aren't maxed. But so that's what that looks like. And that's where we've left off. Okay? With connecting old to new. But I don't want to keep doing the cheat pyramid. I don't want to have to make all this work. I don't want to do all of this all the time. So how do we do this? I'm going to give you about 10 more seconds if you're writing this down, but you should be able to just look at your own. Okay, you have a periodic table in the middle. Whoops, hold on. All right, so you should, is this bold? Is there a line here and here? Okay. You need to view the periodic table like blocks. So there's a block here, there's a block here, there's a block here, and then there's a block down here. First, let's make sure we understand this block before we get into this too much. The line right after, please connect that to the top, and the bottom, connect it like that. Just, it will help you. It's a little confusing. Periodic table actually is wider than this, and it breaks open, and this actually fits inside. It's like you break this apart, and this actually goes there. But you'd have the smallest periodic table, where you'd have to have really long, like covers of your books all the time. So why not just plug it underneath? Okay, what one of, don't write this down, but of S, P, D, or F can fit 2 electrons? And only 2. S, huh? What block only has 2 in the width? There. Which one do you think this block is? Look on just one row. How many are there? There's 6. So that's the P block, we'd call that. This is 10. Which one is that one? The D, and this is 14. It's going to be the F. Let me show you how it works. You don't have to write every one of these. But every one in this column is an S1. So for example, this is a 2S1. This is a 3S. What do you think? 2. This would be a 4S1. This is a 5S2. This is a 6S1. I mean, we could fill in every one of these if you wanted to. The first column's S1. The second column's S2. Where do the large numbers come from? The row. So I could have, you could have, looked at RB and immediately gone 5S1. Fifth row, first column, 5S1. Let's go to the P's. This is the second row, P1. This would be 3P2, 4P3, 5P4, 6P5. Every row is P1, P2, P3, P4, P5, P6, because there's 6 of them. The row itself is your energy level, right? So like this would be 7P3, whatever it needs to be. So the last column, I hope we agree, would be P6, except for helium. It's weird. Helium is actually just S2 because it's first row. Can't be a, do not do one P6. Like, it doesn't work like that. This one's a little weird then. Please write, and if you want to make an extra note, you definitely can. N minus 1. N means the energy level. So if you remember your, and this is where people get confused. So if this is the confusing part, just hang tight because realize that the rest of this probably makes more sense to you and this is the part that's more of a hang up. What happens after 4S? Where did we go on a cheat pyramid? That's the one weird part. 4S, then 3D. So what am I saying? I'm saying that these are one behind the row. So this would be 3D1. I'm not going to do every one of these. You can help me out. This would be 4D what, do you think? 3. Yeah. This would be 5D5. This would be 6D7. 3D8. 4D9. 5D. Okay, you can write whichever ones you want. If you're like, I'm only going to write what he writes. I'm just picking different ones to give you examples. I know I skipped some. I'm just trying to show some examples. In fact, we should write these two. Please write these two right here. This is 5D1, because this is a weird spot. And this is 6D1. What's weird is when you come in through here, technically you actually hit the D1 first, then you jump down. Now, if you looked at the cheat pyramid, you know this. It's very rare to get into the F's. It just is. You got to have a really big element. So, again, if this is the part that's going to mess you up, we'll get there. If they're 2 behind, if this is the 6th row, this would be 4F. I know that's like, whoa, what? It just is what it is. Most things are dealing with the S's and the P's and a little bit of the D's. F's are really rare. But it's 2 behind. So I'm having you track this. This goes here. So that'd be 4F1, right? This would be 5F1. I'm not going to label every one of these. Let's just go to the end. This would be 4F14, 5F14. I don't think we need to do each one. So we're going to utilize this, and we're going to do the back, or the bottom of your sheet, and then the back side, and it's going to make more sense, I hope, without doing a cheat pyramid. Okay? All right, Ms. Newbar, if you want to flip it to the. Yep. So, do I need to turn the lights on in the front or not? So let's look at the bottom here. It says CS. We're going to do the entire thing. So the bottom of the front is CS. I'm going to do the entire electron configuration without the cheat pyramid. And why am I not using the cheat pyramid? Because the periodic table is my cheat pyramid. Wait, what? 1S1, 2S, 2P, 3S, 3P, 4S. It's the third one. 3D, and then it goes back to 4P. We follow the order, and I'm going to show you that we don't need it all. So please follow along with how I do this. I need to get to here. Like, oh my gosh, look at how much I have to do. But all I got to do is look at the table. I need to plow through all of these elements. And we're going to do one big one on purpose here. So every time I go all the way through it, I max it out. So I know in the beginning, it's got to be 1s2. Please write that down, and then we'll start getting into it. So H and HE would be 1s2. Then here, I got to go all the way through that. So that would be 2s2. I'm on the second row. I'm in the P block. That's 2p6. I jump down. This will be 3s2, right? This is 3p6. You don't have to be like, oh, what comes next? I just look. Oh, this is 4s2. And now what is all this? That's the one you have to keep in mind. That's 3 Ds. And I go all the way through it. So Ds have 5, so it's automatically 10. It would be maxed out at 10. So it would be 3D10. Again, I'm not looking at any, I'm just looking at a periodic table. This is now on the 4th row, though, still. 4p6. Almost done. What's this? 5s2. What's the next one I'm writing? 4d10. And then he's like, well, when do I stop? When I get to my element. I'm going to write 5p6. And if you're like, I don't remember what number I'm on, look at the energy level. 5p6. Now end at 6s1. Now, I did a large one on purpose. But, noble gas configuration. What's the noble gas I use? I'm on the 6th row, so I need to go to xenon. So I make a bracket. Please make it a bracket. And then what do I have to do left? All I got to do is get to the element. Oh, I'm right there. I'm done. 6s1. By the way, just so you know, the rule is that you have to go to the noble gas on the previous level. So if, let's just say xenon was the question, you can't go xenon and then be done. You're like, sweet, that was easy. You'd have to use krypton. You're like, but it's a noble gas. Why can't I put it in a bracket? It's always the previous row you have to use. So even noble gases have to follow the noble gas configuration. Electron shell notation. How many shells am I making? 6. I'm making 6. So we put a 4, 5, 6. I'm not worried about the lines. I'm worried about the number of them. So if you're confused or you have this written down and you're not sure, you'll have some other information. Well, that has to be 2. That's maxed out. Okay? The second level can only have an S and a P. There's the second level. That has to be 8. What's my 3? My third level. It'll be 2 and the 6 and the 10. What are you looking at? I'm looking at the big number. I got to find all the 3s. That'll be 18. What I'd like you to do, finish it up. Find them all. See if you match up with me. Uh-oh. They'll never know. It's true. All right, let's do a little comparing and contrasting, all right? So we're going to move on. Hopefully you got it down. 2, 8, 18, 18, 8, 1. And what does that all equal? 55. But how can we even use this in an easier way for us? So please jump to the back. What if I give you that? Okay, let me give you some tips. What looks, you could add them up. You could add them up. 2 plus 2 plus 6 plus 2, but don't do this. Don't add them up. 6 plus 7 plus 2. What is the one that looks incomplete, like it's not filled or it doesn't look right? It doesn't have to be the last one. That is where, I mean, it would be on the cheat pyramid, but that is actually where the last electron is placed. You have to find something that doesn't look full. So how do I do this now? I simply find 3d7. How do I do that? Where is the 3ds? The 3ds are right here. So what is 3d7? CO, cocaine, right? Oh, it's not? Okay, so that's how I do it, by the way. You have to figure out what gives me that information. If you're like, I don't get it. Well, if I go backwards a little bit, it would be 3s2, 3p6, 4s2. You end at 3d. You actually would have ended. Oh, but they didn't put it like that, right? Sometimes you got to kind of figure that out. Noble gas. What am I writing? AR, because it's on the previous row. Then, it's a little more complicated. Don't trust in what's at the ending. What do I draw next? This is important to kind of just recognize how the periodic table works for us. It's everything on this row until I get to my element. I'll say that again. After the noble gas, everything on this row until I get to my element. So this is 4s2 and this is 3d7. Well, that's not the order you have it. I understand that, but this order actually makes more sense to the periodic table's order, which the periodic table is my cheat pyramid. It's actually the cheat pyramid. So I'd like you right now to make the electron shell notation. How many shells are you making? 4, correct? It's on the 4th row. Yeah, but you said a 3D, but it's in the 4th row. So 2, 8, 15, 2. All right? Okay. All righty. Next one. We're doing really well. Okay. We are not going to do this part because we just don't have the time. But how do I figure out what it is? First off, what row does it have to be on? Just the row. Like 1 through 7. Why do you know that so quickly? Because of the xenon. I'm not looking at all this, even though that is the largest number. Right? The largest number does tell me that. But it has to be on row 6 because of xenon being on 6. So here's the problem. Just understand this. By the way, if you're not understanding what this says this row is from LA, right here, all the way to LU. That's what this one is. And this one's right here. So it's somewhere in this and here. Could be any of that. So, what jumps out not being full, being maxed out? So, for example, S2 is full, right? So that I couldn't have ended there. F14, is that full? Yeah. Couldn't have ended there. Now, if they're all full, then I got to figure out which one's last. So, which one did I end at? The P2? Because you can get up to P6. So, this is my hint. So all you got to do is locate 6, level 6, block P, and then 2. So 6P2 would be peanut butter. Right? Peanut butter, plumbing, of course. All right, next one. This one we are going to do it fully. What I'd like you to do, as we hand out the worksheet, I'd like you to try to get, this is the last one we're going to do. We're not going to do the last example, and in the bottom we're not going to, well, I'm going to tell you what it is, but we're not going to actually do anything else. Well, just get to the, let's finish this one first. So we're going to hand out some worksheets to you, and then we'll come back together. Figure this one out right now, please. It's not overly confusing. We didn't do a lot of F's today, which we could talk about eventually, but what element is this? Bromine. It's bromine. It's 4p5. 4p5. It's the fifth one. P1, P2, P3, P4, P5. So noble gas should be Ar, if I'm reading that correctly. Right? So now, before I lose you on here, let's just go over this one last time. Guys, everything after Ar I need to include. So I got to go through all this. I got to go through all that. And then I got to get up to Br. So that looks like a 4s2, a 3d10, and then 4p5. Those are the ones I need. By using the periodic table, so it looks like I need 4 levels only. So if you did this right, it should have been a 2, an 8, 18, and a 7. Okay. So tomorrow, we're going to review, we're going to talk about the Olympics as well, and what your job is for Monday. But we will review a little bit more on quantum numbers again, because we haven't seen those in a little while, and then just continue to work on this stuff. On your worksheet, please flip it over on Electrons 3 for one moment. There is a paragraph. Make a line above that paragraph, and don't cross it out, but make a note or something that right now, for sure, you don't need to do anything below it. So the worksheet just got a lot shorter. Okay? So what is that? What's the last problem? 14? So 1 through 14 you need to do, okay? So, today, Electrons 2 is due by the end of the day. Tomorrow, claim test lab and this sheet. This isn't very long. There's not a lot on here. On the front, I gave you a lot of help with different kinds of periodic tables, so you don't even have to have one in front of you. Okay, so, if you have any questions, let us know.